we have seen how to create a pod deployment and services using imperative commands. Okay, now we'll do the same using manifest. Okay, so we'll also learn what are manifest. Okay, so till now we did it using an imperative command like this. Okay, we created a deployment. Okay, now the equivalent of this, okay, equivalent of this imperative command is below declarative manifest. Okay, so whatever we write it in a YML format is called as manifest in Kubernetes. So most of the times I'll be referring it as manifest. Did you create the manifest? Where is the manifest? Like this I'll be asking. So we refer the YML files for Kubernetes as manifest. Okay, so generally it is just a key value pair. We learned about it when we learned about Ansible and all. Okay, so similarly here we will be having key value pairs, nested key value pairs and all. Okay, so here if we compare it, okay, here we are saying create a deployment called nginx deployment and use image nginx. Okay, so here also we are saying that create a deployment. Okay, the name of the deployment is nginx. We should have 3 replicas. Okay, and use nginx as an image. Okay, so this is the format for most of the deployments. Okay, so if you see, the first part will be common. Okay, at least till name, only the name will change. Okay, then this is for the replica set, how many replicas we want. Okay, then this is for the container, or you can say pod. So if you see the first 3 part, okay, API, kind, metadata and name. So the API, kind, metadata, and you can say spec also, not name. This is the spec. This part, the explanation for this is API version. Okay, what API group of the object and what its version. Okay, so the API group is we want to create a deployment and the version is v1. Okay, I'll tell you how to get these apps v1 and all. Sometimes it will be v1, sometimes it will be alpha 1, beta, some like that. And then the next is kind. Here if you see the kind, what kind of deployment you are using, what are you creating, pod, service or something else. We are creating a deployment. Okay, then the metadata, what are the things that uniquely identify your Kubernetes object. Okay, so we are giving it a name that it is, we are creating an nginx object, nginx deployment. Now the specification, what should be the state of your object, which image to use, any other configuration. Okay, so this is the specification till end. Okay, in that we have some sub specifications as well. This is for replica set, this is for container and all. Okay, so this is how the manifest is written. And let me open the slide. So if you see this slide, okay, so here we are defining deployment. Okay, then if you see here we'll be having some labels. Okay, so this is the label. Okay, so for the specification and means actually for a container we are giving a name as label, app is nginx. Okay, then also for the replica set, okay, here replicas are defined, app equal to nginx. So this is the label given to this deployment, you can say that nginx. Okay, so when we create a service we need to select that label. Okay, that's why here we in service we'll be saying that for this deployment whose label is app equal to nginx, app equal to nginx, create a cluster IP service. Okay, so here we'll define the label and here we'll be selecting it. So this is an example for cluster IP, this is an example for node port. Okay, and if you open this link, okay, so it will give workload resources. Okay, so for pod, when we create, if we create a pod, we need to remember, right, API version what should be the, which is the latest one. So here it is saying when we create a pod, use version v1. Okay, similarly let's check for deployment. Okay, so deployment also apps v1. So if you see it here, okay, apps v1. Okay, that's what it's all about. And labels and selectors are very important. That also I have explained. So if you see the diagram again, so this is the deployment. First part is definition of the deployment. Instead of HTTP it is nginx. Okay, so we are saying that we are creating an nginx deployment. Okay, till specification is it is the deployment name. Then the replicas we have defined here. Okay, the replica set. Okay, and the last definition is for pod. Okay, here we defined the labels app equal to nginx, app equal to nginx, and we are referring this app here when we create a service. Okay, that we are selecting this label. Okay, and for this service, or you can say for this deployment, create a service. Means to expose this deployment, we'll be creating this service and we'll be accessing the pods. Okay, so labels and selectors are very important. Now let's proceed with the lab. Okay, so this is the lab. Create pod deployment and service using manifest. Okay, so only for the demo purpose we'll be creating pod only in this exercise. Next for next exercises it will be directly deployment. Okay, because when we create a deployment it will also create a pod. So let's start this exercise. Okay, so if your Kubernetes cluster is ready, you can also follow along with me. kubectl get all. Okay, we do not have anything. I have done the cleanup. Now I'll just create a directory so that all the manifests are there if you want to refer. So I'll just create a directory called manifest. I'm inside the manifest directory. Okay, I'll first create my pod, httpd pod I'm creating. So we are not creating here the deployment but a pod. So history grep pod. So it is actually equivalent to this command. Okay, kubectl run httpd pod image httpd. So we are saying create an httpd pod. We have labeled it as an httpd app equal to httpd. Okay, and we are saying the image should be httpd. Okay, so our pod definition we have created the pod. Now let's create a service for it. In order to access it, we'll need a service. Okay, so we are creating a service IP, service cluster IP service. Okay. So this is the cluster IP service. Here we are referring, we are selecting the label selector, the label app equal to httpd for this pod. Okay, create. So here we are not defining the type. Okay, we are just saying that on port 80. So here the port and the target port. If you see there are two things, port and target port. So this is the service IP will expose it on port 80. We can expose it on any other port as well. Okay, this port only, not the target port. Target port will be always 80, because the container runs HTTPD runs on port 80 only. Okay, so this is the definition of cluster IP. When we do not define the type here, it will by default consider it as a cluster IP. Next, we'll create a node port. So here we have created the node port. So let's quickly check it. We have pods, cat HTTPD pod. We have pod. Then we have a cluster IP. Okay, and we have a node port. So if you see here, we have defined only the difference is type node port, and the last one would be for load balancer as well. So the load balancer is missing, but I'll add it. Okay. So what we'll do is we'll just copy it, cat. Let's copy it and change CP node port to the load balancer LB, or maybe it is down somewhere. Now here I forgot. So I've copied it. I'll just modify it. The only difference is we'll just change the node port to load balancer and the name. Here it will be load balancer. And name should be LB. We can give any name, but we have given segregated is with CIP, node port and load balancer. So we also have a load balancer service. Now let's apply all. kubectl apply -f httpd pod. Okay, pod is created. Now httpd service cluster IP is created. Next we'll create a node port, and then we'll create load balancer. So instead of apply, for the first time we can use create command as well. Okay, instead of apply we can do create as well. But the next time when we modify this, okay, this files, if you modify and when we try to do kubectl create, it will say that it already exists. Okay, so apply will what it will do, it will also create if it is not there, and it will also uh, not give you any warning that it already exists, and it will modify it. So directly we are using kubectl apply instead of kubectl create. So kubectl get all. Okay, so if you see, the pod is running. Okay, and we have the cluster IP. Okay, and the node port. Okay, the due to as the screen is small, it's showing it here. Okay, so here this is the node port. Okay, and we have the load balancer as well. Okay. So let's quickly test it. kubectl will have to go inside the pod because this DevOps VM is not part of the cluster, so it will not give the details. Only for the load balancer it will give the details. For other things we'll have to go inside the pod and test it. kubectl exec-it interactive terminal for pod. Okay, --bin bash. We are attaching a bash shell to pod's bash shell, and if you do curl localhost, okay, internally the pod runs on port 80. Okay, so we'll have to install it. kubectl update apt-get update and apt-get -y install curl. it shows. Now we can also access the cluster IPs. So as I said, whatever may be the service, there will be always a cluster IP. Okay, so for all the services, these are the cluster IP. Okay, and this is for Kubernetes. So we can test the cluster IP service which we created. Okay, now to test the node port, okay, we'll have to get the IPs of the nodes, that is worker node, kubectl get nodes -o wide. Again, go inside the container and just do curl, and on what port number it will be on, this is load balancer, this is node port. So let's check for node port. Okay, it works. It will also work on the other node. Okay, as the name suggests, it's a node port which is open to the outside world, but not recommended in a production, only for testing. That's why for production we have only load balancer. Okay, so on node port also it is available. And from the outside world, just kubectl get all. Okay, and if you do curl from anywhere, it will work. This is the load balancer. Okay, this is working. If you check on the screen as well on the browser, it will show it works. Okay, so this is how we create a pod. Okay, and the services using manifest. So kubectl get all, kubectl delete. Okay, I'll delete the pod. Okay, so one of the method is, if we do kubectl get all, it will show everything. So it is pod/httpd. So I can delete it using copy paste. One of the other method is, okay, like this, pod/ or I'll specifically tell that delete this pod. So the pod is deleted, and remember, when we delete a pod, as it doesn't have a replica set, it will not recreate it. Once deleted, we cannot recover it, or it will not try to auto heal. Okay, only for the deployment it will auto heal and recreate the pod. Now I'll delete even the services, kubectl delete cluster IP, I'll delete load balancer, and even the node port. So the deletion of load balancer will take time.